This coming October, Tesla is all set to release the Model 2, a budget-friendly electric car with an estimated price of around $25,000. But there is more to this price tag than just affordability. What truly makes this story exciting is the groundbreaking technology behind it. Tesla plans to build the Model 2 using a gigantic machine called the Giga Press, which can apply an astonishing 50,000 tons of pressure. Elon Musk has made it clear that this vehicle will be offered at a low cost, which means the demand will likely be off the charts. To handle such overwhelming demand, Tesla needs a machine that can work at lightning speed. And this machine is not just fast, it is revolutionary. Imagine a car being made in just a few seconds. That is no exaggeration. Welcome to Amp Drive, your source for everything Tesla and beyond. If you are new here, make sure to hit that subscribe button and be part of this exciting journey into the future of electric vehicles and advanced technology. We are a growing channel with fewer than 1,000 subscribers, and your support really helps us bring you more great content. Now, let us explore how Tesla is bringing a $25,000 car to life right now. For people who grew up around the time of the classic Chevrolets and the roaring sounds of traditional auto assembly lines, the thought of casting the entire underbody of a car in mere seconds might sound like something out of a science fiction story. But Elon Musk is not just imagining this, he is making it happen. Quickly and boldly. And then, as Musk casually remarked, maybe we just need even bigger casting machines. Why not 50,000 tons? He believes that eventually a car could roll off the production line in under 5 seconds. Imagine that, a whole car ready in the time it takes to tie your shoes. That is truly impressive. What is even more amazing is how it all began. One day, Elon Musk picked up a small toy model chess, a Hot Wheels version. These tiny models are made using injection molding, which is why they are cheap and everywhere. That simple moment led Musk to ask why not use a similar approach to build full-sized cars? What seemed like an offhand comment turned into the spark that ignited a full-scale industrial transformation. Musk then began the search for a company that could build a die-casting machine large enough to turn this vision into reality. 5 companies rejected the idea, saying it could not be done. Only one company, the Idra Group based in Italy, responded with a hesitant maybe. And from that maybe, Tesla began shaping the future of auto manufacturing. It started with the 6,000-ton Giga Press, used to mold the rear underbody of the Model Y. This alone replaced over 70 individual parts with a single solid aluminum casting, simplifying production enormously. Then came the 9,000-ton press, tailored for the Cybertruck's massive structure made of stainless steel. But now, the big question is, what will the 50,000-ton Giga Press be capable of? Could it truly cast 5 underbodies for the Model 2 at once? That would be a feat unlike anything we have seen before. The Model 2, Tesla's upcoming compact electric car, is designed with short front and back overhangs. Unlike the Model Y, which consists of over 200 structural parts, the Model 2 uses only about 80. That is a reduction of more than 60%, an incredible improvement in design efficiency and cost control. Tesla has already proven that Giga Press machines are a game changer. The 6,000-ton machine builds the Model Y's back section. The 9,000-ton version casts parts of the Cybertruck's body. These machines reduce costs, improve production speeds, and deliver stronger, more efficient structures. So why not just use the 6,000-ton Giga Press for the Model 2, which is smaller than the Model Y? That is a fair question. The answer lies in Tesla's ambition. The 6,000 and 9,000-ton machines are only capable of making parts of the car's frame. But Musk wants to mold the entire underbody in one shot. That goal demands a machine with much greater power. This is where the 50,000-ton Giga Press comes in. No other car maker has dared go this far. While some Chinese brands have tried to copy Tesla's casting approach, none have reached this level. Tesla keeps moving forward, refining the technology, making the machines more powerful and precise. The process begins with melting aluminum alloy in a huge industrial furnace. Once it becomes liquid at high heat, it is poured into a mold shaped to match the specific part like a car's frame. The Giga Press uses incredible pressure to force the aluminum into every quarter of the mold, leaving no room for defects. This casting process has to be timed perfectly. If the liquid metal enters the mold too fast, it traps air bubbles. If it goes too slow, the metal cools before it fills the mold completely. The Giga Press uses advanced cooling technology to avoid these problems, ensuring the metal solidifies evenly and forms a perfect piece every time. Once the part is solid, a robot arm removes it, trims away any leftover material, and moves it to a quality check station. These cast parts are lighter, stronger, and more precise. That saves Tesla time and materials while improving the vehicle's strength and efficiency. The casting process is so effective that it has inspired other automakers to follow Tesla's lead. Companies like General Motors, Hyundai, Volvo, Zyker, and XPeng are all trying to develop similar giga casting setups. XPeng has even launched a 16,000-ton press. But Tesla is still far ahead, preparing to unleash the massive 50,000-ton Giga Press. When Musk first mentioned this colossal machine, people were left wondering just how big will it be? Where will it be installed? How long will it take to get it working? And could it really pump out tens of thousands of Model 2 units every single week? Elon Musk revealed that the new press will be fully automated and operate at such high speeds that humans will not be able to go near it. Everything from pouring the molten metal, managing the mold cooling, to removing the final part will be done by machines. The pace will be so fast, it will seem unreal. Each casting cycle is expected to take about 5 seconds. That means Tesla could potentially build an underbody faster than you can say Giga Press. To house this beast, Tesla will need a specially built facility. Imagine a machine the size of a 3- or 4-story building laying on its side. It may weigh over 3,000 tons, stretch 65 feet long, and stand as high as 50 feet. It will also require a deeply reinforced concrete base to support its massive size. This new Giga Press will feature at least 5 molds, allowing it to cast 5 vehicle underbodies at the same time, something never done before. Here is how it works. Tesla starts by melting down aluminum, both fresh ingots and recycled scrap from earlier castings. The metal reaches temperatures of about 1,562 degrees Fahrenheit. Impurities are removed and the purified aluminum is transferred to a holding furnace that keeps it hot and ready. The holding furnace uses nitrogen gas to prevent oxidation. It also features filters, argon gas, and a rotary degasser to eliminate particles and maintain high purity. Before each cast, robots spray a fine layer of soybean oil over the mold to help with release. Then, a vacuum removes air from the mold cavity. The molten metal is injected into the chamber using a piston that is lubricated before each shot. Due to the huge size of this machine, the liquid metal travels longer distances than in traditional casting. That makes precision extremely important. Too fast and bubbles form. Too slow and the mold is not filled properly. That is why the timing, temperature, and pressure must be tightly controlled. After injection, the aluminum cools inside the mold to around 752 degrees Fahrenheit before being pulled out and dropped into a cooling bath to bring its temperature down to around 100 Bashan, 22 degrees Fahrenheit. This fast cooling strengthens the material and eliminates hidden flaws. Afterward, robots clean the mold and prepare it for the next cast. The next cycle starts in just a minute or two, keeping production moving at top speed. Any leftover metal is cut off and recycled to be used again. To ensure quality, the parts go through X-ray scans that look for structural weaknesses. These inspections are fully automated using artificial intelligence to maintain the highest standards. Keeping the mold closed during casting is one of the hardest parts. That is where the 50,000-ton clamping force comes into play. It keeps the mold sealed tight, even under the pressure of molten metal, preventing any leaks or shifts. Elon Musk explained that to reach this level of performance, Tesla had to create new systems, lightning-fast cooling, intelligent mold release, and AI-driven quality checks. No other car company has done this before on such a large scale. This approach is more than a clever idea, it is a complete shift in how cars are made. It is faster, cleaner, and more space-efficient. Tesla is borrowing ideas from electronics production and applying them to cars. That means lower costs and higher volumes, opening the doors to making top-quality vehicles available to more people than ever before. Lars Moravi, Tesla's vice president, revealed that even the Model Y's backframe has been redesigned. The new version is about 15 pounds lighter and takes half the time to machine. That makes the vehicle stronger, more efficient, and better at handling sharp turns. Since 2020, Tesla's Giga casting has gotten smarter. New cooling channels inside the molds speed up casting on the 6,000-ton machine from 170 seconds down to just 75 seconds. The result is a Model Y that is more consistent, more precise, and more affordable. Oddly enough, Tesla has not applied Giga casting to the front section of the new Model Y yet. Lars Moravi says this is due to current technical and economic limitations. Tesla also launched a new version of the Model Y in China called the Model Y L. It features 6 seats, a longer wheelbase, and a bigger third row, turning it into a smaller and more affordable alternative to the Model X. But the real story here is the 50,000-ton Giga Press. It raises the bar for what is possible in automotive production. By simplifying the car's structure and slashing the number of robots needed, Tesla is paving the way for low-cost, high-quality electric cars. It also places intense pressure on companies like BYD, XPeng, and NIO to catch up. They may have government support and access to big markets, but matching Tesla's technical edge will not be easy. Especially since Tesla holds proprietary knowledge about its aluminum alloys and manufacturing processes. This is Amp Drive, and this is the future of electric vehicles. If you found this story exciting, please hit that subscribe button and stay tuned. We are just getting started.